supervisor is Dr. Nofriza Lidris Bindaris, and today I'm going to present about the topic flow analysis of intake manifold using the computational fluid dynamics. So let's proceed to the abstract. Intake manifold is the most important element in the air intake system. So this is the main component that determines the value of flow that will be allowed to be used in the combustion chamber. The main aiming of this study is to analyze the velocity flow distribution in all runners and also to compare the design with the previous study design of intake manifold. Simulation are performed on these two types of intake manifold design, which is design 1, the inlet end is located at the side of the regulator chamber, while the design 2, the inlet end is located at the middle of the chamber. So intake manifold parameters such as velocity distribution, unevenness, and also pressure losses along the runner were used to determine the better design for a better performance. From the result, the velocity and pressure of intake manifold of these two types of design show the airflow line graph is gradually increased by 0.05% of the percentage difference compared to the previous study. Further, the pressure losses of the intake manifold design 1 followed the previous study values as a bench to measure the validation of this numerical simulations result, and the design 1 achieved the range of acceptable value, which is in between 2500 Pascal to 3000 Pascal. This is the introduction of this study, which is in this paper the three-dimensional of two types of intake manifold for engine were established. The model was developed with tetrahedral and shear stress transport was used by using NCCFX software. The 3D design was conducted by using software NCCFX, and the velocity contour of the intake manifold were obtained. The study provided the basis for the optimization design of the intake manifold to achieve the velocity flow distribution in all runners and also to compare the design with the previous study design of intake manifold. So this is the objective of this study, which is to analyze the velocity and the pressure distribution in all runners of the intake manifold and also to compare the different types of intake manifold design. And then scope of study, which is analyze and compare the velocity distribution with the previous study for 11, 13, 15 and 18 meter per second. Analyze the pressure losses between the intake runner for both design. Intake manifold design 1, the inlet was located at the side of the regulator chamber, while design 2 was designed at the middle. Inlet end was located at the middle of the regulator chamber. All the data establishment of the intake manifold performance obtained from computational fluid dynamics and CCFX only. So this is the methodology of this research, which is we can see the PSM2. We run the simulation. After we run the simulation, we validate the data with the previous study and we plotting the graph. But if we doesn't satisfied with the graph, we just repeat the simulation and validate again. But if we satisfied with the data, we just analyze the data and go to discussion and recommendation. We proceed to the result and the discussion. So for the velocity distribution, as we can see at the side, we can see the velocity contour plot of the airflow travel from the inlet end to the outlet of intake runner. So at the top, for the first picture, we can see that it was design 1, which is the inlet end was located at the side of the regulator chamber, while the figure second one is the inlet end was located at the middle of the regulator chamber. So as we can see, the maximum airflow velocity is around 33 meter per second, while the minimum flow velocity is around 4 meter per second for both design. Okay, so as we can see at the velocity contour, the color of red clearer can be seen at the first intake runner when it opened. Then followed by the second runner open, the color of red contour become dimmer, continue until the fourth runner. The color of red contour become dimmer as we can see at the design one. So the airflow velocity of the intake manifold which is we can conclude that the airflow velocity of the intake manifold which is far away from the inlet end is large, and the airflow velocity near the entrance end is small. And then moreover, the same situation goes to the design 2, which the first runner of the design 2, which is the red color, looks dimmer compared to the design 1 of the first runner of design 1, and this shows that the flow velocity for design 1 is better than the flow velocity of the design 2. So let's proceed to the next parameter that we discussed, which is vortex phenomenon and unevenness, which is we can see from the velocity contour, there are more eddies at the intake runner at first and fourth runner for design 1, while design 2 occurred at the second and the third runner. So this phenomenon is called as a vortex phenomenon, which can cause the increases of the flow resistance, and the unevenness of the flow air distribution is also one of the factors for having a better performance of the engine. The percentage difference between design 1 and design 2 and previous research is as the percentage difference between design 1 and previous research is approximately 4%. This shows that the airflow evenness of intake manifold design 1 is better than the design 2, and the design is reasonable. So let's proceed to the last discussion, which is pressure losses. The pressure losses is below 3000 Pascal is used as a reference in this study due to the previous study report. So design 1 got the uniform, as we can see the plotting graph of inlet, intake manifold, outlet runner, and the pressure losses. The design 1 got the uniform pattern for all the runner while design 2 got the unstable and higher pressure losses. And all the runner of the design 1 does not exceed the preference value, which is in between 2500 Pascal and to 3000 Pascal, and this shows that the geometry design of design 1 is feasible, and as the different pressure losses between each runner are approximately around less than 1%. So for a conclusion, numerical simulation of two types of intake manifold system was conducted and flow field of intake manifold was analyzed. The comparison of intake manifold design 1 and 2 with the previous research had been investigated in this present study. So the result shows that the inlet end arranged at the side of the regulator can greatly improve of the intake uniformity, as it improve the intake efficiency of the engine and combustion quality. So the findings also indicate that the airflow design 1 is good for a better performance during the lower percentage of the calculated unevenness, and also the lower pressure losses compared to the design 2, which the inlet end is the middle of the regulator chamber. Based on the computational fluid dynamic theory, the three-dimensional numerical simulation of the engine's intake manifold system is carried out, which is an effective and feasible method of analysis. The result shows that the pressure losses and flow uniformity of intake manifold are two major evaluation indicators and the design 1, as we can see, design 1 meet these two design specifications. So this is the reference that we refer. Thank you for watching this video.